So you don't have to memorize them. Which ones am I responsible for? So I'm going to start calling on people, and all I want is a figure. A figure you're going to be responsible to know the area formula. And also, we have a couple formulas that aren't associated to a polygon. They're a formula to find something else we've talked about, so you can tell me that too. All right, so let's get started. What figures or just formulas that are not associated with the figure that we're going to have to know a week from today? Because let's just go over it now, because I am not adding to this list this week. Not adding to it. Simon, what are we going to need to know here?
Rhombus.
Rhombus. That is one you need to know, not on the formula sheet. So we're going to put it right here. Rhombus, that's on you. And I'm not going to waste time going over these because we'll have a day of review on Friday. So rhombus, yep, got to know that formula. On you. Let's go. Jared, no. Jared, yep, go. Parallelogram. Not memorized. That's on the formula sheet. Parallelogram, good. Others we're going to need here. Let's go, Vinny. Trapezoid, on you. Along with the rhombus. That's not given on the formula sheet. Trapezoid. What else are we going to need here next week? Jonathan? Circle, given. That's given. Again, it might not be a figure. It might just be something we talked about that is associated with the formula. So I think I'm looking for a couple more here. 1, 5. Where we got, Alexi? What else? Triangle, given. Yep, triangle. And actually, there's 5. All right, anything else here? Anything else? We've gotten most of the figures here. Bailey? Rectangle, yep, that is on you. I know it's just length times width, but hey, it's not on the formula sheet. Rectangle. All right, so you guys went over all the figures. These are all the figures we've had area formulas for. Now I'm looking for 2 more formulas that aren't really associated with the polygon. All right, but we need them to find this topic. And we did them day 1 and Friday. Dylan? Sector. We just did it on Friday. Just went over homework on it, right? It's area of a sector. Part of a circle, area of a sector. And then one more, we did it on day 1 with the triangle and parallelogram, where we went over Alaska, New Jersey in the United States, the highest and the lowest of, Lauren? Population density. There you go. Okay, population density. And now that I think about it, I'm going to add one more here to the one that's on you. And that is when I ask you to graph a figure and ask for the area, and you have, I don't care if you know what the figure is, if you have a formula or not. There's one always go-to method to find the area of a graphed figure, and that's your box method. Darn right, I'm going to be putting that on there next week. All right, your box method. All right, so there it is. Again, I'm not adding to this list this week. We're just practicing some different things, including today. I'm gonna only have 2 problems to do with you today, and you're doing the rest. All right, any questions? And I'm here all week after school if you want to stop in. 1 week from today is your test. All right, here we go. Let's go over today's topic. Again, I'm only going to do 2 problems with you, 2 and only 2. We're going to start using actually, let me go back to Friday's class. Remember Friday's class, end of class, I was like, hey, let's take these 2 figures, boom, smush them together, what's the area? And it was very clear to everyone, oh, that thing on top's a trapezoid, that thing on the bottom was a half circle. Very clear. Now what I'm going to do with you today is, I have no idea what that figure is, but you know what I can do? Break it up into figures I am familiar with. These are called composite figures. All right. I have no area formula because I don't even know what the thing's called. But you know what we can do? Break it up into figures we are familiar with. So I'm going to do part A with you here, this composite figure. I'm not going to assume that's a trapezoid. It might be, but I don't know. All right. Let's see. It's got 1, 2, 3. Actually, it's not a trapezoid because it got 5 sides. So what am I calling it a trapezoid for? That thing's got 5 sides. No idea. A pentagon, but do we have an area formula for a pentagon? Nope. All right, but what I can do is I can break this up into figures we are familiar with. Everyone see a horizontal or maybe a vertical line that you can draw in here to break this up into two figures? Not only are we familiar with, but we have formulas for it. So I'm going to ask somebody what line you want to draw in, a horizontal or a vertical, because we could do either one right here. What are you drawing in right now in your figure to break this up into figures we're familiar with? Horizontal, vertical line. What do you got, Drew? Vertical, you got it. That's what first period did. I'm assuming it's right here, Drew?
Yeah.
All right, yep. You could draw that in right there. Hey, if some of you guys chose to do the horizontal like this, try doing the problem like that. We should come up with the same answer. We're not going to get different results. I'll go with Drew's vertical line again right here. Do you see what Drew broke it up into? Rectangle on the left, trapezoid on the right. Those are two formulas. Those are two figures we have formulas for. All right, so we're going to find the area of a rectangle. Notice I'm doing the same thing I did Friday with you. If you guys don't want to write out I don't care. It's not going to offend me if you don't write out what it is. Plus trapezoid. And then I substitute in the formulas I should know for them. Length times width plus trapezoid. 1/2 height. Base 1 plus base 2. I don't need to see this for you guys to get full credit. And I know it drives some of you nuts, but you know what? The more you write the formula, the closer you get to 100% memorization by next Monday. All right, that's my philosophy. Every time you write it out, you get closer to memorization. All right, let's start rectangle. How about the length and width? It's already up there for you. Start us off right. Length and width of that rectangle. Cormac?
Length is 12.
Okay, 12 times 18 for the rectangle. 12 times 8, sorry. Plus 1/2. All right, look at the trapezoid. The height. One height's already there. It's this right here. That's one height. Or you could draw in the other yourself from right there to there. It's your call. I'm going to just use the one I had there first, which is that height. Anybody want to explain to me how I can get to that height? Height of that trapezoid using the measurements you have there. How can I get there? Drew, back to you. You wanted to draw this vertical line in, so how do I get to that height?
15 minus 8.
Good. Rectangle, opposite sides congruent, so that's 8. Drew can subtract. That's why he's in this class. 7. And now what about the two bases? What about my two bases here for the trapezoid? What are the base lengths here? Cormac, back to you. The trapezoid. The bases, I got to put in B1 and B2. Did you draw that line? Okay.
Base 1's 12.
Yep.
Base 2's 5.
Just explain to your classmates how you. I can see the one base is 5 because it's written on there. How'd you know the other base was 12?
Because it's the same height as the height of the
There you go. Opposite sides congruent, a rectangle, 12. And there we go. So we're going to break these up into figures we are familiar with. And now you just number crunch on the calculator. Rounding directions are on top if you need them. Down to the nearest tenth. And we're all looking at 155.5 square inches. Don't forget your units. Don't forget them. Don't forget your units. All right, don't do B and C. I'm going to let you have plenty of time to do that on your own or with other people. Any questions about the composite figures, breaking it up into figures we're familiar with? All right, the other type of problem we're going to work with today is called the shaded region problem. Okay, shaded region problem. If you want to go ahead, label that diagram with the given measurements, go ahead. All right, shaded region. Why? Well, why does the technique we just used for composite figures not work? Well, I don't know if I'll be able to break. That's not a figure I'm familiar with right there at all. I don't know if I can find that length I just drew in. So I'm I'm going to hold off right there. All right. Shaded region problem. Here you go. If you want to find the area of any shaded region, some of you probably have done these before, I'm sure, in the middle school. You take the whole thing, which we're familiar. That's a figure we're familiar with, aren't we? The whole thing. We take the whole darn thing minus the unshaded part, which is a figure we're familiar with. Take out the unshaded, you get the shaded. All right, it's not really a formula. It's just take the whole thing and subtract out whatever is unshaded from it. What is this whole thing we are familiar with? What is it? It's right there. Tess, what is this bad boy? The whole figure. It's a rectangle, so I'm going to take area of a rectangle and subtract out what's the unshaded figure up here. Unshaded figure, Shara?
Oh.
The part that's unshaded, that is a triangle. There you go, guys. Two figures we're familiar with. We should be able to find the area of both. Length times width for the rectangle minus triangle, 1/2 BH. We're familiar with it. All right, going back to you guys. Length and width of that rectangle so I can find the area of it. Length and width. Zoli? 6 and 15, multiply them together. Minus 1/2. All right, I'll give you a second here. What's the base and the height of that unshaded triangle MBA? Don't look at it as two right triangles. Look at it as one full one, triangle MAB. What would be the base and the height? Height always drawn to the base. What's the base and the height of that unshaded triangle right there? Jared?
15.
Yep.
And 4.6.
4.6 is definitely the height. And we've always talked, that height has to be always drawn to the base. The base can be any of the three sides, but the height's always going to be drawn to the base you want. Jared knows opposite sides in a rectangle are congruent, so that's how he knows that side's 15. And there we go. Area of a shaded region, the whole thing minus the unshaded part. $55.5 for that polygon's area. No unit, so I don't expect any. All right, here's the deal now. Rest of the class, I'm done. Rest of the class, you can work on your own. You can work with the people in your group. And hopefully I don't regret doing this. You can move around and work with other people as well. I'm going to write all three answers to B, C, and E up here. If you are struggling to get one of them, call me over. Not a big deal. I'd rather work with you one-on-one than you guys just writing down with the answers and moving on. You get done, move on to the assignment. You know those answers are on Classroom. All right, so go ahead, work with whoever you'd like here. Hopefully I don't regret that decision, but I think you guys are mature enough to be able to. I'll write the answers up here. And call me over if you need my help. B, C, and E. Make sure you remember your units. Feel free to work with whoever.